In this presentation, we'll discuss hardware definitions such as VHDL and Verilog. Designing complex systems and integrated circuits is difficult without the use of computer-aided design tools. Schematic capture tools such as CircuitVerse can help us with drawing block and interconnections at different levels of the design hierarchy. However, schematic capture tools and Boolean equations are good for small circuits, but they don't scale well to more complex circuits. Hardware definition languages have become crucial to modern design process, and these resemble software programming languages. They can focus on parallel operations performed by the hardware. Hardware definition languages can represent more than just schematic information. In fact, they can represent Boolean equations, truth tables, and complex operations such as arithmetic. In top-down design, a very high-level description of an entire system can be precisely specified using an HDL. We can keep refining until we get a final description with primitive components. We can also simulate the resulting circuit. The major reason for the increased use of hardware definition languages is logic synthesis. An HDL description at an intermediate level can be converted into an interconnection of primitive components that implements a circuit. The logic synthesis tool takes care of a lot of the design details and allows designers to explore trade-offs for different designs. Currently, VHDL and Verilog are both widely used. The standards for these languages are maintained by the Institute for Electrical and Electronics Engineers, IEEE. That means that VHDL and Verilog are portable. However, schematic capture tools are often unique to a specific vendor. Regardless of your choice of an HDL, you need a process to employ an HDL description and simulation input. The steps in the procedure are analysis, elaboration, and initialization, followed by simulation. Analysis checks the description for violations of syntax and semantic rules. Elaboration traverses the design hierarchy represented by the description, and at the end we get a simulation model which is passed to the simulator for execution. We can describe fairly complex hardware using HDLs. Testbench is a description that includes the design to be tested, or device under test. The Testbench describes a collection of hardware and software functions that apply to the device under test and analyze the outputs for correctness. Construction of a testbench provides a uniform verification mechanism that can be used at multiple levels in the design process. Logic synthesis tools have driven a lot of growth in hardware definition languages and are used to transform register transfer language of a circuit into an optimized net list of elements that can be laid out using physical design tools. What you see on the right is the simple high-level flow of the steps involved in logical synthesis. We begin our process with an HDL description of the circuit, a set of constraints, for example, allowable fan-outs, speed, etc., and a technology library. The technology library describes primitive blocks available for use in the final netlist as well as their physical parameters, for example, delays. The first major step in the synthesis process is the translation of the HDL into an intermediate form. This may result in an interconnection of generic gates and storage elements that are not from our technology library. The second major step is optimization, which processes the intermediate form in an attempt to meet the constraints. Optimization can be very complex and time-consuming for large circuits. The final step is technology mapping, which replaces the and/or gates and inverters with gates from the technology library. The final result is a netlist that goes to the physical design. Thanks for watching. Be sure to check out La Lima for assignments and more. We'll discuss VHDL and Verilog in more details in separate presentations.